What's up guys, welcome back to the channel. Today on this video we'll be doing this question paper that you see here, which is a national certificate for mathematics and 5. This paper was written on the 25th of November 2025. It took about 3 hours to be written. So on this particular video though, we're going to be focusing on question 2 of this question paper. We've already done question 1. If you want to watch that question 1, you can go to the description. I'll leave that video, and also the very same video of question 1 will pop up on the top right of this question as we speak now. All right, people. So I'm gonna create timestamps so that you can watch a question that you desire, just in case you don't want to watch in a sequence order. Before we start though, I'd just like to say thank you very much guys for watching, subscribing to the channel, commenting, and also not forgetting those who like and share the video. Now let's look at question 2. Now here is our question 2. Question 2 is actually derivative. So consists of 20 marks. Okay, so let's go and do question 2.1. So let's read the question. So question goes like this here. Determine dy over dx in each of the following cases. And the following instruction is given here. Simplification not required, meaning when we differentiate these questions here, we don't need to simplify. You just differentiate it once. Alright, let's look at 2.1.1. Now, as you can see, this question here, it's a chain rule. So they want us to differentiate this. So as you can see, we have a function within a function within a function. So it's a chain rule. So let's identify these functions here. So let's start with the whole equation. So we have this one here. I'm gonna highlight with blue. It's everything, including the power there. Okay. So the one that is in blue, it's everything that is include the power. Then let's look at the ln. So we have one for ln. Let me highlight with green. I hope you guys can see this. Okay. And then we have the one inside there, which is all of this inside the bracket there. So we actually have to derive all these. So as you can see, we also have an expression that has a root there. We need to change that. So before we differentiate, how about we simplify first? So we're gonna have ln to the power of 3, open bracket, we have x squared minus 5x plus, and then instead of writing the root, we can put it inside the bracket and write the exponent. So what is the exponent in terms of root? We know that is the power of half, and then we close the bracket. So when it's like this, it's easy for us to differentiate. Again, let's highlight our functions there. We have ln to the power of 3. Let me highlight very quickly. And then we have ln. Let me highlight with green there. And then we have the inner part there. There we go. So what we have to do here, guys, is we need to differentiate each and every expression that you see there, and we multiply them. So let's start with the one with ln to the power of 3, right? Dy over dx, right? Now this one is the same as when you have f of x to the power of n, right? When you differentiate this, this is gonna give you n f of x n minus 1. There we go. So our f of x here, it's actually ln 3 with everything inside there. So let's do it. So if we use this, remember this is 3, so that 3 is gonna be there. As you can see, that is n there. And then we multiply with f of x. So f of x, which is ln, this time around we say ln 3 minus 1. So this is gonna give us 2 there. There we go. And then you write everything inside there, guys. It's gonna be x squared minus 5x plus, and then open bracket, x squared minus 7 plus 20 to the power of half. You close the bracket because you have these brackets there. There we go. Then we are done with the one in blue. Now let's do the one in green. Now the one in green, the one that I highlighted in green, is just a differentiation of ln x, right? Instead of x, in fact, we have everything that is inside there, which is x squared minus 5x plus open bracket, x squared minus 7x plus 20 close bracket to the power of half. The derivative of ln x, we know that it's going to be 1 over x, but instead of writing 1 over x, remember we have to multiply by it. Going to be 1, right, divided by everything that is inside there, which is going to be x squared minus 5x plus open bracket x squared minus 7x plus 20 to the power of half. There we go. So this is the one in green there. There we go. Let me just create a line here. I hope you guys can see. Right. Then we are done. Now let's differentiate the one in red, the one inside ln them. As you can see there, we have individual terms, and also we have the one with the power of half. So let's start with the x squared there. So you have to open the bracket. When you differentiate x squared, it's going to be 2x, right, minus 5, because the differentiation of 5x is 5, plus, then inside there, remember we have open bracket x squared minus 7x plus 20 to the power of half. So we have to use this formula again, because we have f of x to the power of n, which is half there. When you derive it, we must multiply by n, which is our half there. So it's going to be half. There we go. Multiply by everything that is inside there. So it's going to be x squared minus 7x plus 20. There we go. To the power of, remember, if we use this formula, we know that it's going to be n minus 1. So our n here, which was half minus 1, is going to be negative 1 over 2. Then we multiply by the derivative of the expression that is inside here. We have x squared minus 7x plus 20. So we have to derive that. So derivative of x squared is 2x. The derivative of 7x is going to be 7 there. 20 is 0. So this is basically how you derive this. Remember, they say do not simplify, but you can if you want to, which is not necessary. Let me just do it to make our life easier. So this here is going to be 3 ln 2, and then we write everything that is inside there, x squared minus 5x plus open bracket x squared minus 7x plus 20 to the power of half. There we go. And then close bracket. Multiply by 1 over this one here. So if you multiply by 1 over, let's do it this way. Multiply by 1 over x squared minus 5x plus open bracket x squared minus 7x plus 20 to the power of half. There we go. Multiply by everything here. So inside there, let's not forget to put the bracket. So we're going to start with this one here, which is 2x minus 5, right, plus half. There we go. But instead of writing this x squared minus 7x plus 20 to the power of negative half, we're going to change this, the power of negative half, into a positive. So what we're going to do is we're going to continue multiply by 2x minus 7. So it's going to be multiply by 2x minus 7, and then all this is going to be divided by x squared minus 7x plus 20 to the power of positive half, because we changed that into a positive exponent. So the denominator become a numerator become a denominator. So we close the bracket there. So this is our final answer. Don't simplify it further, people. In fact, here it's fine, but if you wanted to simplify it further, this one's gonna be okay. So this is how you differentiate this type of a problem. The chain rule, guys. So you differentiate the outer part, which is ln to the power of 3, which is this one here, right? Differentiate it there, and then you must differentiate the ln on its own, which is this one here that I highlighted with green there, and then you must differentiate to what is inside ln there, which is all of this. There we go. So I hope you can able to see that, guys, because this is a bit challenging, especially if you're not familiar with chain rule. But anyway, I hope you managed to understand. If you did not understand, leave a comment or watch at the point where you got lost. If that doesn't help, you can leave a comment. If this video helped you to understand how to derive this type of problems, don't forget to like, share the video, subscribe to the channel if you haven't subscribed to the channel. Alright people, we are done with this question 2.1.1. Let's go into question 2.1.2. Alright, here is our 2.1.2. Now they want us to differentiate this expression that you see here. As you can see, we have inverses of trigonometric ratio. We have the inverse of sec and the inverse of tan. Now you need to know these derivatives. They are there on your formula sheet. For arc sec, for example, for arc sec x, it is written like this in your formula sheet: dy over dx. It's supposed to give you 1 over x root x squared minus 1. Alright, you can also write it like this: arc sec f of x. Instead of writing x, you substitute with f of x. Then when you derive this one, it's going to be dy over dx. Okay, we're going to have f of x prime on the numerator. Instead of writing this one, it's f of x prime. Divide by. Now instead of writing x, remember we write f of x there, and then root. Then we're going to have f of x, let's not forget squared there, minus 1. There we go. So if we derive using this here, I prefer to use this one here. Guys, it's the same, just in case you get confused with this one here. If we derive using the one underneath there, arc sec f of x, it means our f of x here, it's actually x squared. This one here, it's our f of x. There we go. So the derivative here, dy over dx, is as follow. We say we have the derivative of f of x, which is on the numerator there, so it's gonna be 2x. Remember our f of x here, it's actually x squared, right? Divide by, right? So let's look at this. We have f of x there. Our f of x, we said it's x squared, so we're gonna write x squared there, and then root, right? Then what is inside the root? We have f of x squared. So our f of x is x squared, so we're gonna have x squared minus 1. So we have 1 there, right? So this is the derivative, right? Plus. Now let's look at the derivative of arctan. Now the derivative of arctan, if you go to the formula sheet, it's gonna be as follow. It's 1 over 1 plus x squared. There we go. Or we can write in this manner: arctan. Instead of writing x, we can write f of x there. And then when we derive this, dy over dx, it's gonna be divided by 1 plus f of x, but squared. There we go. So this is how you're gonna do this one there for tan. Now let's look at our f of x. As you can see, our f of x for tan there, it's actually 1 minus x over 1 plus x. This on its own, it's actually the quotient rule. Now the quotient rule, we have a formula for it. Remember, when you derive the quotient rule, you need to derive the one on the numerator first, and then you multiply by the one on the denominator, then you subtract, and then this time around you derive the one on the denominator, you multiply by the one on the numerator. Then all of this is going to be divided by the denominator square. So our f of x, like we said, it is this one. So let's derive our f of x. 1 minus x divided by 1 plus x. You can start with the one on the numerator. The derivative on the numerator, we know that is going to be negative 1, right? Multiply by 1 plus x. So if we derive 1 minus x, it's going to be negative 1. Multiply by 1 plus x, then minus. We leave the 1 on the numerator, which is 1 minus x there. Multiply by the derivative of the denominator, it's 1 plus x, which is going to be multiplied by 1. Okay, then we divide there. We divide by 1 plus x, then close bracket, we square them. This is a quotient rule, guys. Just in case you don't know it, you can go to the description. I'm gonna leave a video where I explain the quotient rule, and also the very same video will pop up on the top right of this one that you're watching. All right, so let's continue. We are not done. We are done with f of x prime, this one here. Now it's time for us to multiply by 1 over 1 plus our f of x. Remember this one here or that one here, it's 1 minus x divided by 1 plus x. But let's not forget, we need to square it based on this here. So this is the derivative of the equation that we have there, 2.1.2. All right, we are done with 2.1.2. Let's go and do the next question, which is 2.2. All right, guys, let's look at 2.2. Now 2.2, they want us to calculate the dy over dx if we are given y, which is equaling to 3 to the power of x ln x squared with aid of logarithmic differentiation. So we need to use log to differentiate this. First of all, we need to introduce log both sides. So we have y is equaling to 3 to the power of x ln x squared. If we introduce log on the left hand side, we're going to have ln y, right, equaling to what you do on the left hand side, you must also do on the right hand side. So we're going to have the following there. There we go. So some people might get confused. Ln is already there, but as you can see, it's there as an exponent. It's not there as a base. So we have to introduce ln when it's like this. From here, let's simplify. So on the left hand side, we have ln y there. And then on the right hand side, if you simplify, we can take this exponent there to the front. There we go. Now let's do it. We can say x ln x squared multiplied by ln 3. There we go. This is a rule. When you have ln x to the power of 2, you can use this rule here. You can take 2 to the front, you'll be left with 2, and then ln x. That is a rule for logs. I hope you guys know about these rules here. So that's what we did here. All right, so this is it. As you can see here, we have two functions that are multiplying each other. We have x and we also have ln x squared. These are two functions multiplying each other, multiplying the coefficient, which is ln 3 there. So let's continue. So we have to differentiate this. So when you differentiate any function that has y, it's a implicit. So let's do it. So it's gonna be dy over dx, remember, multiplied by 1 over y. The derivative of ln y, it's 1 over y. But let's not forget, we are deriving with respect to y. We have to multiply by dy over dx, then equaling to. Now ln 3, it's a coefficient. You can write it on the side there, then open bracket. Then you apply the product rule. Guys, this is a product rule. X multiplied by ln x squared. That is a product rule. So I can write this as f of x, and then this one is g of x. There we go. I hope you guys understand this, right? So let's derive our f of x. Our f of x is 1. So it's going to be 1 multiplied by ln x squared. There we go. Plus. Now the second one, we derive g of x. Let's start by writing our f of x here. And then our g of x, we start with ln. When you derive ln, it's 1 over x squared multiplied by. Now let's derive our x squared there. It's going to be 2x there. Then close bracket like that. Right, let's continue. Dy over dx, right, multiplied by 1 over y. We have ln 3 there, and then multiply everything that is inside there. So the first term here is 1 multiplied by ln x squared. So this is just going to be ln x squared, right? And then our second term, we have plus them. We have x squared dividing x and that x there, multiplied by 1. So this is going to be 2 there. Now if you continue, we're going to have the following: dy over dx, right, multiplied by 1 over y. We remove the brackets, we're going to have the following here: ln 3 multiplied by ln x squared plus 2 ln 3. There we go. But we're not done. We have to cross multiply this y there. So the final answer is going to be dy over dx. This is equaling to y, and then open bracket, we have ln 3 multiplied by ln x squared plus 2 ln 3, close bracket. But we are not done. Remember, y is equaling to our original expression there. So let's do it. So dy over dx is actually equaling to 3 to the power of x ln x squared, open bracket, ln 3 multiplied by ln x squared plus 2 ln 3, close bracket. So this here, guys, is our final answer. Okay, some of you can continue and do it this way: 3 to the power of x ln x squared, open bracket, and then we can take this 2 to the front. Okay, let's take it to the front. We're gonna have 2 multiplied by ln 3 plus 2 ln 3. Okay, you can take out the common factor here, which is 2 ln 3, so you can write it as 2 ln 3 multiplied by 3 to the power of x ln x squared, open bracket. So if you take out this one here, we're going to be left with ln x there plus 1. So this is can be your answer as well. But people, you can stop here or there. It's really up to you guys. So this is how you do this one. Just in case you didn't understand, again, you'll have to rewatch at the point where you get lost. And if that doesn't help, you can always leave a comment on the comment section. Guys, most of these derivatives, we have done them on N4. That's why I don't dwell on them that much. If you don't know how to do a log derivative, I will leave a video that is based on natural log derivatives. And also we have a chain rule there and a product rule as well. So I hope you were able to see how to derive these two rules here. Okay, people, thank you very much for watching. If this video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed. We are done with 2.2. Let's go and do 2.3. Here is our 2.3. Now we're gonna start with 2.3.1, but let's see what is it that we're supposed to do here. As you can see from 2.3, they say given the implicit function, so meaning we need to do implicit here. We have x squared multiplied by y plus cos, open bracket, pi over 2 multiplied by y, close bracket, minus 4x squared is equaling to 5. So this is an implicit. So they want us to find dy over dx. So let's continue. We have the first term here. We have x squared plus y. This is a product rule, guys. Again, you have to use the product rule. Now, if you use the product rule for this one, let me open the bracket. We're going to derive x first. So we're going to have 2x. There we go. Because x squared, the derivative of x squared is 2x multiplied by y. Right. Then plus. Now this time around we leave that x squared, we derive y. When we derive in terms of y, we know that we're gonna have dy over dx. There we go. Then close bracket plus. Now let's look at cos. Now cos, we have cos pi over 2y. Now we need to derive this. So if we derive cos, if you go to the formula sheet, you know that we have to multiply by the coefficient. What is our coefficient there? It's pi over 2 then. Now the derivative of cos, we know that it's going to be negative sine pi over 2y there, right? Close bracket. Since we are deriving cos in terms of y, let's not forget we multiply by dy over dx. There we go. Minus. And then we have negative 4x squared. So this is going to be 8x. All this is equaling to 5. What is the derivative of 5, which is a constant? It's going to be 0. Then from here, we need to group all the terms with dy over dx together and the terms that does not have dy over dx. Let's first remove the bracket and multiply by negative there. If you remove the bracket, we're going to have 2x y plus x squared multiplied by dy over dx. There we go. Minus, because we have this minus here, right? Pi over 2 sine pi over 2y multiplied by dy over dx minus 8x. All this is equal to 0. From there, we're going to transpose these terms here because they do not have dy over dx then to the right hand side. So we're going to be left with x squared multiplied by dy over dx, right? Minus pi over 2 sine pi over 2 multiplied by y there multiplied by dy over dx. Right, so let's transpose these terms here. If we take this negative 8x, this is going to be positive 8x. If we transpose this positive 2xy, this is going to be negative 2xy. So as you can see, on the left hand side, we're left with terms that has dy over dx. So dy over dx is a common factor here. We take it out, dy over dx. On this term here, we want to be only left with x squared. On this term here, we're going to be left with negative pi over 2 sine pi over 2 multiplied by y there, close bracket. And all this is equaling to 8x minus 2xy. Right, so let's create space, guys. We have to divide by all of x squared minus pi over 2 sine pi over 2y. So we have to divide by all of this. We have to divide by all of that. So if we divide on the left hand side, we're going to be left with dy over dx. On the right hand side, we're going to have 8x minus 2xy divided by x squared minus pi over 2 sine pi over 2y. There we go. So this here is our answer for the question here, which was 2.3.1. So we are done with this one. Again, guys, this was implicit. Just in case you don't know much about implicit, this is how you do implicit, guys. So we are done with this question. If you didn't understand, you can rewatch at the point where you get lost. And if you have a question, you can leave the question on the comments. But if this video helped you to understand how to derive such questions, do not forget to leave a like and also subscribe to the channel if you haven't subscribed. Share the videos to your friends. We're done with 2.3.1. Let's do the last question, which is 2.3.2. As you can see, I didn't erase the first workout of 2.3.1 because this question here, 2.3.2, it needs us to use the equations or the expression that we just got them. So let's read the question. The question goes like this: determine the equation of the tangent of the graph of the point x is 1, y is 2. So guys, what we have to do here is to substitute our values on our expression that we got them. So I'm gonna do it here on top where we have dy over dx there. Wherever there is y and x, we're gonna substitute with these values here that we have there. Right, so our expression there, we have 8x. Instead of writing x, we're gonna write 1 there, right? Minus 2x multiplied by y. So instead of writing x, we're gonna write 1, and then instead of writing y, we're gonna write 2 there, divide by. So this is where things get tricky. Let's start with the first term on the denominator. X is 1, so it's gonna be x squared, which is 1 squared there. Now minus this one here, it's pi over 2. There we go. Then it's sine. Instead of writing pi over 2, guys, as an angle, you can write it as 90 degrees. Remember, pi over 2 multiplied by 180 divided by pi. This here is the same as 90 degrees. You can write it as 90 degrees. If you decide not to use the rads on your calculator, right? So I will write it as 90 degrees multiplied by y. What is our y in this case? It's gonna be 2. There we go. Then you put this on your calculator. Let's put it on our calculator. Dy over dx. If you put it inside the calculator, our final answer here is gonna be 4 on the numerator divided by 1 minus 0. So the final answer dy over dx is actually 4. There we go. All right, so from here, what you should do is to determine the equation of the tangent. Guys, a tangent, it's a line that touches a circle once. So that's a tangent. So the equation of a tangent, it's the equation of a straight line. So we know that we have this formula, y is equaling to m, which is the gradient, x plus c. What you should know is that dy over dx is equaling to the m, which is our gradient. So this here is the same as m, that for them. So if we do have the gradient and we have x and y, we can find c. So y, based on our point there, is going to be 2, is equaling to 4, which is our gradient, multiplied by 1, which is the coordinate of that point there, plus c. There we go. So if we continue, we have 2 is equaling to 4 plus c. So c is equaling to negative 2. There we go. So the equation of this here is create space, guys. The equation of this expression, it's as follow. It's gonna be y is equaling to our m, which is 4, the gradient, multiplied by x minus 2. So here is our equation here, guys. I hope you managed to understand how to do this one as well. It was not difficult, but it needed you to understand how to find the equation of a straight line, because the tangent is actually a straight line. Just in case you didn't understand, you can rewatch at the point where you got lost. And if that doesn't help, you can always leave a comment there. But if this helped you guys to understand, do not forget to like, share, subscribe to the channel if you haven't subscribed to the channel. We are done with question 2. It was a bit complex, but really it was understandable. Just in case you want to watch question 1, I will leave the video with the playlist that has question 1 and also other questions of this question paper. Right, people, thank you very much for watching. Till next time, cheers.